Hello, welcome back. Let's do a lesson on dilution. Hopefully this goes pretty quick. It's just some simple algebra for today. Let me just set the stage for dilution. You have a solution. It could be any kind of solution. The examples I think I'll use today, though, will probably either be an acid or a base, just because that's what unit we're in. But it could be a sugar solution or a salt solution. Doesn't actually matter. But again, we'll use an example of an acid just for giggles. So you have a solution. Let's call it hydrochloric acid, and you decide to add a bunch of water to it. When you add the water, you dilute the solution, right? So the concentration has changed. The question is, what is the new concentration? If you knew the original concentration was, say, zero point 0.1, what's the new concentration? Is there a way to figure it out? There is. It's very easy mathematically. It's a little algebra. So that's what we're doing today. All right. Here we go. The equation that we're going to use is, I call it MV, which is on your reference sheet, I believe. And also, it's very simple. The M and the V stands for molarity and volume, and it's the same on both sides. The only difference is on one side, you're talking about the molarity and volume of the solution before you added the water, concentrated solution essentially. And on the other side, the equal sign is the molarity and volume of the solution after you added the water, and therefore it's the dilute version. The possible way to add a little complexity to these problems is to ask a question like, how much water did you add? What's the amount of water that you added? And it's really simple. The only difference between a diluted solution and the concentrated solution is you added water, right? So that's the only difference in volumes as well. So if you subtract those two volumes, you should have the exact amount of water that you added. So when you're asked how much water was added, you just have to simply subtract the two volumes, and you'll know the volume of the water that was added. Here we go. Let's try a problem because these are so straightforward. It says 500 milliliters concentrated solution of 8 molar hydrochloric acid was diluted to 2,000 milliliters. What's the new concentration of the solution? So we actually know both pieces of information for the solution before you added water. We had 500 milliliters, that's the volume, and it was 8 molar concentration of, and again, this happens to be a hydrochloric acid solution, but it could have been anything. So that's the concentrated side. On the dilute side, we actually don't know the concentration, the molarity concentration. That's our unknown. But we do know the volume of our dilute solution. So we have 3 of the 4 variables. We should be able to solve for the 4th using algebra. So let's do it really quickly. I'm going to try and draw, and this is generally not going to go well, but we'll do the best we can. Go yellow. So I'm going to put the molarity of the concentrated solution, which was 8 molar, 8.0 molar. By the way, Ryan just texted me and said, isn't that 1 significant figures? And I'd say no, because there's a decimal point right there, so that makes that 503 significant figures. And this has a decimal point right there too. See, now you can see it better. And that has 4 significant figures. And 8.0, of course, has 2 significant figures. So our answer is going to be in 2 significant figures. You're welcome. Anyway, that's the concentration, 8.0 molar. Where does it keep disappearing? It's playing a joke on me. 8.0 molar hydrochloric acid is the concentrated concentration, and the 500 milliliters, the volume of our concentrated solution. That's awesome. I should teach a class on writing with mice. We don't know the concentration of our dilute solution. I'll write that as X. You can pick whatever letter you want. You can label it as M if you want. And that is multiplied times the volume, which it says right there is 2,000 milliliters. Solving, I learned in algebra class, you gotta isolate your unknown. So I'm going to divide 2,000 milliliters on both sides. That is very clearly a 2,000. Oh boy. The units, you don't have to convert any units as long as they match they're going to cancel off. So milliliters and milliliters, they match. They're going to end up canceling off right about 2 seconds from now. There's my 2,000 milliliters. This whole side cancels except for the unknown x. On this side, we've got milliliters divided by milliliters. Gone. We've got 8.0 molarity. That unit is still around, still kicking. So that's going to be in my answer. What about the numbers? I had 8.0, not 80. I don't know why the decimal place keeps disappearing, but this is 8.0 times 500 divided by 2,000. Now, if you can't do that in your head, because 8 times 500 is like 4,000, just guessing, we'll use our calculator. 8.0 times 500 divided by 2,000. It is 2. We're going to say 2.0 for 2 significant figures. Right, Ryan? Yes. And there's our answer. The new concentration of the solution after we added a whole mess of water is now 2.0 molarity. See how easy that is? Easy as can be. Let's keep going. I got to hit this button, I think. Yeah, there we go. How about this question or this example? It says, how much water, remember that little tricky one, I guess? How much water should be added to 500 milliliters of 8 molar hydrochloric acid to dilute the solution to 1.0 molarity hydrochloric acid? So the question isn't asking what's the volume of your dilute solution, although we'll have to figure that out. The question asks how much water should be added. And remember, when we're talking about how much water did we add, we just got to subtract the two volumes. We know the first volume is 500 milliliters. What's the second volume? Let's figure it out. Same idea before. Rather than painfully write that again with the computer, which was a mess, I'm just going to go jumping right into it. On the concentrated side, I have 500 milliliters times the 8 molar of our concentrated solution. On the dilute side, we have our unknown volume times the 1.0 molarity. So I've got 500 milliliters times 8.0 molarity is equal to unknown times 1.0 molarity. .500 times 8 dividing by 1 molar on both sides means the molarity units cancel. I'm left with the same exact 4,000. Milliliters didn't cancel, so that one's still kicking. So 4,000 milliliters is the volume, the final volume of our dilute solution. Not the answer, though. We have to subtract the two volumes, 500 milliliters and 4,000 milliliters. Let's do that right now, and that will tell us how much water we added. 3,500 milliliters of water we added. Done. Let's keep going. Look, there's the answer. All right, last. Can you do this? Let's have you try. So pause the video after you read this, but how much concentrated 12 molar hydrochloric acid will I need in order to make 2,000 milliliters of a 1 molar hydrochloric acid solution? So we're diluting the 12 molar solution. The question is, how much of that concentrated solution do we start with and then add a whole mess of water in order to get to the 2,000 milliliter mark? And at that point, we should have 1 molar hydrochloric acid. Pause it and figure it out. Okay, welcome back. Hopefully you have the right answer. I'll just put it in the calculator really quick and you can check your work. Get rid of that. We know the dilute information was 2,000 times the 1 molar. The concentrated has the unknown. It was unknown times 12 molar. So 2,000 times the 1 molar. And then I'm going to divide both sides by the 12 molar. So the molarity cancels. We're left with milliliters, and it turns out it's 166 repeating 6 milliliters of concentrated 12 molar acid. That's how much we want to start with. So you got 167 milliliters of HCl, 12 molar HCl. You add water until it finally gets to the 2,000 milliliter mark, and now you have 1 molar hydrochloric acid. This is what I have to do when I mix the acids for our labs all the time. So 166.6 repeating. Looks like we probably want 2 significant figures, so we'll call it 100 and 170 pains me to say, to round off that much, but 170 would be two significant figures. All right. You want to try a hard one? Here's a thinker. Pause it, read this question, pause it, see if you can figure this one out. This is combining today's and the last lesson we did on pH. See if you can figure out the pH of a solution, the diluted solution, not the pH of this concentrated, but we're going to dilute the concentrated solution first. Tell me what the pH is. All right, welcome back. You paused it, and now the question is, do you know the answer? Well, the pH would be 2.03. That's two significant figures. 2.03. If you got that, great job. If you didn't, here's how we did it. First of all, we had to solve MV, today's information. We needed to solve for the concentration of our solution after we diluted it. So originally it was 0.1 molar when it was only 125 milliliters. Then we added a mess of water until it went up to 1,200 milliliters. Oh, no, that's how much water we added. It actually, when you add 1,200 milliliters to 125 milliliters, it equals 1,325 milliliters, 1,325 milliliters of total solution now, dilute solution. Ooh, was that the mistake you made? So that's our final volume. So what's our dilute concentration? Here, let's use the calculator. Oops, wrong button. Calculator. We had 125 times 0.1, and we're going to divide by our correct total volume of the dilute solution, which again was 1,325, and that will tell us our new concentration. That is 0.00943 and change molarity. That's the concentration now of this diluted hydrochloric acid solution. What's the pH of that? Take the negative log. So there's my concentration, log negative 2.025. Again, two significant figures, so that's 0 and then the 2. Those are my two significant figures right there. Because remember, we don't count in front of the decimal place for pH and pOH. So the 2 is our second significant figure. It's not going to stay at 2, though, because that's a 5, so we go rounding up to 3. 2.03, pH 2.03. Well, good job if you got that, and hopefully you understand it if you got it wrong. Probably the mistake you made was the volume. I'm going to guess. That tricks everybody the first time around, or almost everybody. Now you should be able to answer all those questions on dilution. Good luck.